Okay, so get this right. Scientists are now saying that there might be two different kinds of liquid water.
Hmm.
Yeah, you heard that right.
Wow.
Two. We are diving into some seriously mind-bending research about water.
It's going to be a good one.
It is. It
Yeah.
is based on a March 12, 2025 article from SciTech Daily.
Okay.
It's called Water's Hidden Side Revealed. It can exist in two liquid forms at once.
I like it.
Yeah,
Catchy.
it is. It is.
Yeah.
And it's based on some brand new findings published in Nature Physics.
Nice.
So today we're going to unpack this complex research,
Okay.
figure out why it matters, and maybe have our minds blown a little along the way.
I think that's a given.
Yeah, I think so too.
It definitely challenges how we think about water every day.
Right. We drink it, we swim in it, we kind of take it for granted.
For sure.
But water is already kind of a weirdo, scientifically speaking.
It really is.
Would you agree?
100%.
Yeah.
Yeah, think about it.
Yeah.
Water naturally exists as solid, liquid, and gas all at the same time.
Yeah.
Under normal conditions,
Mhm.
it's one of the very few substances that does that.
That's true. Like that ice cube in your glass of water.
Right.
With condensation forming on the outside.
Exactly.
3 states of matter just hanging out.
Yeah, it's wild.
And then there's the fact that ice floats.
Oh, yeah.
Which is bizarre because it means ice is less dense than liquid water.
Right.
Most substances are denser in their solid form.
Yeah, and that's not just a random fact.
Okay.
That has huge implications for life on Earth.
Okay, I'm listening.
If ice sank, lakes and oceans would freeze from the bottom up,
Oh, wow.
and aquatic life as we know it would be pretty much impossible.
So water's already breaking the rules.
It's a rebel.
Yeah, it is.
Yeah,
But this new research adds a whole new layer of strange.
for sure.
Okay, so scientists are saying that under extreme pressure and low temperatures, liquid water can actually split into two distinct phases,
Yeah,
one denser than the other.
it's like two different kinds of liquid water coexisting.
Now that is wild.
It's crazy, right?
And what blows my mind is that this isn't a completely new idea.
Right.
Scientists have actually suspected this for decades.
Yeah, the theory of a liquid transition in water was first proposed back in 1992.
Wow, 92.
Yeah.
But until now, it's been impossible to observe experimentally.
Yeah, too difficult.
So how did they figure this out?
Right?
Was it some top secret lab with like crazy equipment?
Not exactly.
Okay.
This discovery was made possible by some incredible advances in computer simulation.
Okay.
A team at UC San Diego,
Okay.
led by Professor Francesco Pisani,
Mm-hmm.
used molecular simulations, machine learning,
Wow.
and supercomputers to create a virtual model of water under these extreme conditions.
So they basically built a virtual water world inside a computer.
Pretty much, yeah.
That's some next level science.
It really is.
Yeah.
And what they found is fascinating.
Okay, lay it on me.
At a specific critical point,
Okay.
about negative 103 degrees Fahrenheit, and under pressure, 1,250 times greater than what we experience at sea level.
Yeah. Whoa, hold on.
Yeah,
12,250 times normal pressure.
that's right.
Like, to put that in perspective,
Yeah,
that's like being 7 miles beneath the ocean's surface.
exactly.
Oh,
That's how extreme these conditions are.
yeah.
And at that critical point,
Yeah.
the simulation showed the water molecules going absolutely crazy,
Oh, no.
oscillating rapidly between a high-density phase and a low-density phase.
So it's like the water molecules can't decide which form they want to be in?
Kinda, yeah, you could say that.
Yeah.
They're flitting back and forth at incredible speed,
Jeez.
and it all happens at the molecular level.
Oh, wow.
So we wouldn't be able to see it with the naked eye.
That's incredible.
Yeah.
Now, this entire simulation relied on a specific model they developed
Right.
called the MB model.
Mm.
It sounds incredibly complex.
It is a bit complex, but
Can you break it down for us?
yeah. So imagine a room full of people.
Okay.
If you add one more person, it subtly changes the dynamics of the entire room, right?
Yeah.
Well, in simple terms, the MB-Pol model takes into account both the short-range interactions between individual water molecules, which are influenced by quantum mechanics, and the long-range interactions that affect the entire system as a whole.
So it's kind of like zooming in on the individual behavior of the water molecules
Yeah.
and then zooming out to see how they all interact as a group.
Exactly.
Got it.
And because the model is so comprehensive, it's been incredibly effective in simulating this complex liquid transition.
This whole thing sounds incredibly demanding computationally.
Oh, absolutely.
Like, did it require some serious tech to pull this off?
Yeah, the simulations actually ran for almost 2 years, nonstop, on some of the most powerful supercomputers in the world, including Expanse at the San Diego Supercomputer Center.
2 years.
2 years, yeah.
Non-stop.
Nonstop calculation.
Wow, that just boggles my mind.
And without these incredible advancements in computing, research like this would be pure science fiction.
So they essentially built a virtual lab inside a supercomputer to study this liquid transition.
That's one way to put it, yeah.
But here's the million-dollar question. Why should we care about two forms of liquid water?
Yeah.
What does this discovery actually mean for the average person?
Well, that's where things get really interesting.
Okay, I'm listening.
Scientists believe this finding could lead to the development of incredible new technologies. Just imagine synthetic liquids that mimic water's liquid transition, but at everyday conditions.
Okay, now we're talking. What kind of applications could that lead to?
Oh, the possibilities are pretty much endless.
Give us some examples.
For instance, imagine a filter that could pull pollutants out of the air like a molecular magnet, all thanks to a synthetic liquid that can shift between high and low density on demand.
Okay.
Or desalination plants that could turn seawater drinkable using a fraction of the energy they currently require.
Wow.
Those are just a couple of the possibilities.
Those are some pretty compelling applications.
I think so.
So this seemingly abstract discovery about water could actually have some tangible, real-world benefits.
Absolutely.
That's amazing. But is there any way to actually observe this liquid transition in a lab setting? Or is it all theoretical for now?
That's the next big challenge.
No, yeah.
Replicating those extreme conditions.
Yeah.
The intense pressure and low temperatures in a real lab is incredibly difficult.
Yeah, I bet.
However, there's a potential solution on the horizon.
Oh.
Nanodroplet technology.
Nanodroplet technology, what's that?
It involves creating tiny microscopic water droplets with incredibly high internal pressure. All thanks to surface tension.
So it's like creating a miniature pressure cooker for water molecules.
Yeah, pretty much. It's cutting-edge science.
Wow.
And it could be the key to unlocking this mystery in the real world.
This is all so fascinating, and it really highlights how much we still don't know about even the most common substances around us.
For sure.
What we've learned so far is just the tip of the iceberg.
Exactly. This discovery has opened a door to a whole new world of scientific exploration. It makes you wonder what other secrets are hidden in plain sight, just waiting to be uncovered.
Now, that's a question worth pondering.
It is.
It is.
For sure. Yeah, it really makes you appreciate, like, the power of scientific curiosity, you know. This research started with a theoretical idea, and decades later, thanks to some impressive technology, we're seeing that idea come to life, you know, like in a virtual world.
Right.
It's pretty amazing.
And like we've unlocked a hidden level in the game of like understanding water.
Exactly. And who knows what other levels are out there just waiting to be, like, you know, discovered.
Right.
This research could be a stepping stone to, like, all sorts of groundbreaking innovations.
So let's take a step back for a second and connect all of this back to you, our listener.
Right.
Why should you care about two forms of liquid water?
Yeah.
What does it mean for your life?
Well, think about it this way, right? Water is essential to life as we know it. We drink it, we use it for agriculture, for industry, for everything. And as the world's population grows and climate change intensifies, access to clean water is becoming more and more challenging.
Yeah, that's true.
It's easy to forget how precious a resource water really is.
It is.
And that's where this research could really make a difference.
Okay.
If we can figure out how to create synthetic liquids that mimic water's liquid transition, but at room temperature and normal pressure, it could, like, revolutionize everything from water purification to energy production.
Can you give us some specific examples of, like, how that might work?
Sure. So imagine a filter that could pull pollutants out of the air, like a molecular magnet, right?
Yeah.
All thanks to a synthetic liquid that can shift between high and low density on demand, or desalination plants that could turn seawater drinkable.
Right.
But using a fraction of the energy they currently require.
Wow.
Those are just a couple of the possibilities.
Those are some pretty compelling applications.
Yeah, I think so.
So this seemingly abstract discovery about water could actually have some, like, very tangible, real-world benefits.
Absolutely. Yeah, that's what's so exciting about it.
It's a great reminder that even the most, basic scientific research can have profound implications down the road.
100%. I completely agree with that.
It really is incredible.
Absolutely. And this discovery could, inspire a whole generation of scientists to explore the hidden potential of other, seemingly simple substances.
Yeah.
Who knows what groundbreaking innovations await us just, around the corner.
One thing that really struck me about this research is just the sheer amount of time and effort it took to get to this point.
Right?
We're talking decades of theoretical work, years of simulations running on supercomputers,
Uh-huh.
a whole team of brilliant minds working together.
It really speaks to, the persistence and collaborative spirit of science.
Yeah.
This wasn't just some quick breakthrough. This was a long, dedicated journey.
Yeah, and they even had to develop a whole new model just to be able to simulate this behavior of water accurately.
Exactly, the MB pole.
Wambiopol, that's
It
right.
highlights, the importance of developing new tools and techniques to tackle these complex questions.
Yeah.
Sometimes you have to, invent the tools you need before you can even begin to answer the question you're interested in.
It's like they had to build a whole new set of scientific instruments,
Right.
but instead of building them in a lab, they built them in a supercomputer.
Yeah, that's a great analogy.
And speaking of supercomputers, it's incredible to think about the sheer computing power required to run these simulations for 2 years straight.
It's wild, isn't it?
Trillions of calculations per second,
Yeah,
all aimed at understanding the behavior of tiny water molecules.
it's pretty amazing.
It really is, and it's all happening because someone somewhere was curious enough to ask, what if water could exist in 2 different liquid forms?
Right. It all comes back to that fundamental curiosity that drives scientific progress.
Mm-hmm.
Someone dared to ask a seemingly crazy question, and then a whole community of scientists came together to find the answer,
Yeah.
pushing the boundaries of our knowledge and technology along the way.
It's inspiring, it really is, and it makes me wonder what other, seemingly simple questions might lead to groundbreaking discoveries in the future.
Oh, absolutely, yeah.
What mysteries are still out there waiting to be unlocked?
I think that's, the beauty of science. There's always something new to discover.
Right.
And who knows, maybe one of our listeners will be the one to ask that next big question,
Ooh, yeah.
the question that sparks a whole new wave of scientific exploration.
That would be amazing.
After all, scientific discovery isn't limited to, professional scientists. Anyone with curious mind can make a contribution.
That's a great point. So, to all of our listeners out there, never underestimate the power of your own curiosity.
That's right.
The world is full of wonder,
Haha.
and there's always more to learn.
Absolutely.
Well, on that note, we'll wrap up this deep dive into the fascinating world of water.
Yeah, it's been a good one.
It has. It has.
It has.
We've learned that even the most familiar things can hold incredible secrets, and that the pursuit of knowledge can lead to, unexpected and amazing discoveries.
Until next time, keep those minds thirsty for knowledge.
And cheers to the weirdness and wonder of the world around us.